Ladies and gentlemen, in this room you have a poison, and it's not necessarily the person next to you, although it could be. And in this room it's very heartening to see that the best dressed people are the youngest people here, like those people here. And it's their job to take over from us, to knock us off our perch, and to continue fighting for what we strongly believe in. More about that poison in a minute. The gas carbon dioxide is found in space. There are other interesting compounds there. A very common one is alcohol. Some of you would be heartened by that. Leaking out of the rocky planets is carbon dioxide. There is solid carbon dioxide ice on the icy planets and their moons. Leaking out of planet Earth for the last 4,567 million years has been carbon dioxide. Yet the EPA in the US has called this a pollutant. It is a natural gas. And on planet Earth, we can measure carbon dioxide. The current eruption in Hawaii is leaking out huge amounts of carbon dioxide into the atmosphere. But we read in the scientific literature that volcanoes emit very little carbon dioxide. That is correct with the terrestrial volcanoes and not the ones in the oceans or on the ocean floor. There are some 1,800 terrestrial volcanoes. They emit very little carbon dioxide. There are only 3.5 million submarine volcanoes which emit huge amounts of carbon dioxide. We can measure it and we can repeat it by doing experiments on molten rock and working out how much carbon dioxide dissolves in these rocks and how much leaks out when we cool these rocks to make them solid. Carbon dioxide has been on this planet since the beginning of time. We see carbon dioxide coming out of warm springs. We see it bubbling out of ocean springs. There are pools of liquid carbon dioxide on the ocean floor. We see liquid carbon dioxide on the ocean floor bubbling through liquid sulphur. We see carbonates, which have about 44% carbon dioxide in them, precipitated from volcanic fluids. We see seawater circulating through these new volcanic rocks on the ocean floor, dissolving materials out of seawater and replacing these with minerals in the submarine basalts. We are adding carbonates to rocks on the sea floor. You can do an experiment at home with some seawater. Get some seawater and have it in a carbon dioxide rich atmosphere, and it will precipitate dolomite. Dolomite, the rock dolomite, has 48% carbon dioxide in it. In South Australia in the Flinders Ranges, we have sections that are 12 kilometres thick of solid dolomite. We can back calculate and work out how much carbon dioxide was in the atmosphere. And it wasn't a little bit more than now, and it wasn't a lot more than now. It was up to 1,000 times more than now. So we have had carbon dioxide with us since the beginning of time. We are breathing in 0.04% carbon dioxide. We breathe out 4%. If carbon dioxide is a toxin or a pollutant, you should be dead. This room now probably has about 800 parts per million carbon dioxide in the atmosphere, 0.08, because you're all breathing out at a faster rate than the air conditioning can remove that carbon dioxide. So we have been fed the story that there is carbon pollution. And when someone talks about carbon pollution, I give you a couple of questions to ask them. Well, if it's carbon pollution, how come I can see you? Because carbon is black. Don't you mean carbon dioxide? And they'll grudgingly say yes. Then you say, well, just to make sure that we're talking about the same thing, what is the molecular weight of carbon dioxide? You'll get a stony silence. yet they want to argue science with you. By the way, it's 44 if you want to play this game. And so we are now in a world of blissful ignorance about a gas. When I first went to school here in Sydney, in physics, the first thing we learnt was about measurement. And we would measure 10 metres. And not every kid in the class got the same number because there is an order of accuracy in measurement. The first thing you did in the life sciences was to learn about photosynthesis. This is carbon dioxide being used as plant food. This is the fundamental of life. Now the first thing you learn in the life sciences, if you do it at all, is that carbon dioxide is a pollutant. And about measurement, you will learn how 97% of sciences agree with this and that. It's got nothing to do with measurement. That's to do with politics. So we have a real problem with the basics of science. Carbon dioxide is the gas of life. We have had carbon dioxide on this planet ever since the first day. We've had 6 major ice ages on planet Earth. 6 out of those 6 ice ages started when the carbon dioxide content was anything up to 1,000 times higher than now, but 6 out of 6 of them started when we had carbon dioxide higher than now. So how come this gas, which is meant to drive runaway global warming, didn't do it in the past? How come we actually had ice ages in the past? And through my geological eyes, we see absolutely no correlation between atmospheric carbon dioxide and temperature. And without correlation, there is no causation. So it is very clear that this part of my science, geology, that gets totally ignored. Now, in science, you marry science to evidence, which you collect from measurement, from experiment, or from observation. And you try to explain this. That's your scientific theory or your conclusions. And that has to be in accord with everything else in science that has been validated. The climate warmest, and I don't like to use the word science, but what they call as science is not in accord with my science, which has been validated and has been validated for hundreds of years. It's not in accord with my science, so it is not science. It's not in accord with history. It is absolutely unrelated to science. Yet we hear stories about scientists supporting these views. There is one question which you should always keep in your mind to ask people of the other side. Now, I don't meet people from the other side. I don't get invited to dinner parties. Apparently, I'm a real shit and cause trouble. And I basically sing with the choir. But if you perchance happen to meet one of these people, ask them a very simple question and use please. Can you please show me that the human emissions of carbon dioxide drive global warming? No one has ever shown this. But we have assumed in society that the human emissions of carbon dioxide are warming this planet. Now that is despite measurements. Since we've been measuring temperature, we have had significant changes. Since we've been writing history, going from the time of Herodotus onwards, we have been observing crops and we have been observing the effect of cold and warm on crops. In Roman times it was warm. We know that from where they planted their crops. We then came into the Dark Ages, started by solar inactivity, helped along by some dirty big equatorial volcanoes filling the atmosphere with dust. We then came into the medieval warming. The first to feel it were the Vikings, who could then travel huge distances, got across as far as Canada, grew grapes in Greenland. It was warm then. That was a period of great warming. We knew that we'd had warmer periods in the past because the Romans also took their grapes with them, which they grew in Yorkshire. Now, England does produce some wine now. It's dreadful stuff. You replace battery acid with English wine. But we know from where people grew crops what the weather was like and what the climate was like. And in the medieval times, it was warm. Yet we had no industry pumping carbon dioxide into the atmosphere. And you have two alternatives. You can say, well, we have huge natural fluctuations in temperature, or we can change history. Well, that has been done. The hockey stick is a very good example of an attempt to fraudulently change history such that it could be shown that we lived on a benign planet, nothing was happening, no changes, until suddenly we got a temperature rise when we had industry on planet Earth. That is the same thinking that creationists have, a static planet. And for me, climate activism is no different from creationism. It is a fundamentalist religion. It totally ignores the basics of science. It doesn't enjoy the coherence criterion of science, where what you say is in accord with everything else. And it's a mechanism of snaring people into your fundamentalist beliefs. But we have our climate folk who want to scare us witless create models. Now, in exploration geology, we create models. We create those models from an integration of geology, geochemistry and geophysics. And you test a model with a drill hole. We call diamond drills rotary lie detectors because most models fail. We've seen that also in the climate industry. Models of 25 years ago are telling us that today we would have been frying and dying. That's not the case. Those models all show a great increase in temperature because that depends upon what you put into the model and how you tweak the dials. And what has been put into those models have been that carbon dioxide is driving global warming. So we see from the past that that is wrong, we see from the models that is wrong, and there's only one model that works. And that is a model that uses the effect of the sun and the Earth's orbit, and it has very successfully predicted how temperatures have changed in the past. So maybe that big ball of heat in the sky actually drives temperature on the Earth. It's a really revolutionary idea, so I don't want to disturb you so early on a Saturday morning. Our models have failed. And we have also had an assumption that everything was lovely. We were holding hands and singing and dancing through the fields when the carbon dioxide content was at the pre-industrial revolution level of 285 parts per million. Well, that's a wonderful figure to pick because that's one of the lowest numbers you've had in the history of time. And it's a good number to pick because no matter what happens, the carbon dioxide content's going to increase. I don't think that's science. I think that's misleading and deceptive conduct. And we know from the Roman times, we know from the medieval warming, we know that we've had huge natural variability. We know that we've had a pause over the last 20 years or so. We know that there's a lack of correlation between temperature and carbon dioxide. Yet we still cling like a drowning man to these straws that we sinners in a wealthy industrial world are emitting carbon dioxide, and that's going to kill us off. This has got nothing to do with the environment. It's got nothing to do with carbon dioxide. Having spent a lot of my working life in universities, this is all about grant money and keeping the gravy train spinning. It's all about the green power subsidies, which Jo's going to talk about in a minute. I won't talk about electricity, that's for her. This is all about skinning you alive. We are so wealthy, we can create our own South Sea bubble, or we can create our own Dutch tulip mania, and we've done that. And we are getting skinned alive where the science is not underpinning it and the basic foundations are not underpinning. And I argue that this is a result of the dumbing down of science over the last 40 years. And we now find with many young people, and not these young people here, they know the answers before the question's asked. You cannot argue logic with a fundamentalist because a fundamentalist put themselves into that position by not using logic. So we have beyond any doubt that carbon dioxide is not the principal driver of climate. We have beyond any doubt that climate change occurs. It occurs for many reasons, and no Paris Accord can make sure that our Earth's orbit is in the same place, such that we're not far away and cool down or closer to the sun and warm up. There is absolutely no doubt that the data has been manipulated, and Jennifer Marahosi has done a great job on this, showing that we have had changes in primary data. That is a cardinal sin. That has influenced the political game of global warming. Now just imagine if you're the chief executive of a company and you've had a bad year and you've had a loss. Well, what you do is you homogenise your numbers such that you have a profit. Now you go to jail for that as a company director, but that's what's happening in the primary data that is being collected to frighten us witless and to open our wallets. We have the belief, which is a word of religion and politics but not of science, we have the belief that carbon dioxide is a pollutant and that it's dangerous. It isn't, it's beneficial. And if you want to grow a good crop in a glass house, pump in warm carbon dioxide. Look at the last 20 years of planet Earth. We've had a slight increase in atmospheric carbon dioxide and we've had a greening of the planet. We've had increased crops. The industrial effluents and plastics are the real pollutants. It's not the gas of life. So we have had a situation where we have been conned because of the lack of basic science. People like me have been shut down because there's no oxygen, and by the way, that poisonous gas was oxygen. The greatest extinction on planet Earth was due to oxygen, due to a diversification of life, and the eukaryotic life putting out oxygen was killed off the prokaryotic life. There's still a few refugees, you've got them in your guts, but that is the only evidence we have on planet Earth of a mass extinction by a poisonous gas, and it was oxygen. So I don't believe we're dealing with the environment. How can any environmentalist say that despoiling the country with these bird and bat chomping monsters that are made out of highly polluting materials and have to be subsidised to keep the lights on for a short period of time, how can that be good for the environment? This is actually not about the environment. It's about power over you and having unelected groups being able to open your wallet. It's not about energy efficiency. If we were really concerned about energy efficiency, we would join the other 19 G20 countries and have nuclear power in this country. We've got a small reactor here at Lucas Heights, only 20 megawatts. It's a research reactor. It's not about coal. Coal has brought you peasants from your peasant state into the middle class. It's currently happening in China and Southeast Asia. This is not about coal, it's about power over you. And we see that any heretic, like Peter Reid, any heretic gets burnt by the climate inquisition. So we are living in times when pensioners cannot afford to have electricity, where we have a Labor Party that has ignored their workers who are going to lose jobs because the more expensive electricity is, the fewer jobs you have. And we, I believe, are sitting in a period of collective insanity. And the planet goes through that occasionally. And Chris Berg said to me this morning about the advance of science, and he pointed out that science progresses one funeral at a time. So it's going to be a long time to get rid of those who have pushed this propaganda. The only way it's going to happen is for things to get bad, to get really bad, to have mass unemployment, to have people freezing, to have the lights go out on the operating table, which has already happened in South Australia. That is the only way we will get a change. We will not get it from logic, and we will not get it from science. And the only politician is a good, frightened politician, and they need to be frightened. Now, if Warren Mundine can flog his book, I can also. This book came out in October called Climate Delusion and the Great Electricity Rip-Off, and I'm arguing from the fundamentals exactly the story that Joe's going to be giving us, and that is that because of this delusion that gas of life, carbon dioxide, drives global warming, we have now put Australia a country with huge amounts of energy, thousands of years of energy. We now have unreliable energy and over-expensive energy, and we are committing suicide. Thank you.
Thank you very much, Ian, for that. I just wish you'd been my science teacher. I'd have done a lot better at school. Now, Joe is going to speak next, focusing particularly on the energy matter, and I think you're right to go. Great. Welcome, Joe, to the podium.
Ladies and gentlemen, I'm here to explain how to destroy a perfectly good grid in 3 easy steps, or maybe 5. Numbers. For 100 years, we've had great grids. Bountiful, reliable electricity for 10 cents a kilowatt hour. It brought fresh food and perfect temperatures all the way across the country. Got something like a 40,000 kilometre network to 20 million people on the East Coast. Electricity was steadily getting cheaper. Clearly, it was time to change that. To destroy a good grid is much harder than you think. It takes a lot of money, buckets of cash. You have to overcome the free market, which you completely bypass the force of independent competition, which will defeat you every time if you give it a chance. And you have to make sure that consumers can't just pick cheap, reliable electricity. Because, of course, that's what we all want. And, of course, don't listen to an engineer. Put the national electricity policy in the hands of climate modellers, experts in dead mammals, foreign lawyers and union hacks. Now, I'm also here to explain why would you want to kill a good grid? And the answer to that is the joy of blackouts. Vastly underestimated, ladies and gentlemen. They can be fun, and we find out just how much 9 months later. It brings people back to an experience of nature, reminding us how much we don't like being cold or hot or bored or without our computer. It's therapy for screen-addicted kids and their screen-addicted parents. It's great for observing the stars. It's the only time astronomers can work with the dim night sky. As long as they've charged their batteries and put kerosene in the lamps. It's perfect for wood-fired telescopes. And best of all, it is this will be perhaps a bit controversial, but you know, it's the only 100% effective antidote to the ABC. Thank you. It's the only time they're not politically biased. Now, the other side effect of this policy of destroying a grid is we create great jobs, and they're jobs in places with names like Baoding, Haikou and Tianjin and Hengshui, which I've no doubt pronounced incorrectly, because we don't make solar much here in Australia. We don't make wind power either, but we are creating jobs, and good for them. I'm sure they need them. Sorry, I don't know why... that's from another speech on pagan temples that I do. Sorry. The challenge, ladies and gentlemen. The challenge is it's probably harder for us to destroy a grid than anyone else in the world. We really start from a back position on this one. That's because we live in the land of vast resources like you would not believe. We are the largest exporter of coal in the world. We have the 4th largest resources of coal. There's the map of countries with resources. Notably, the 20 countries who signed the We Won't Use Coal declaration are not ones with black dots on them. They were the countries already not using coal who promised to not use coal. There's the Australian exports. Indonesia, curiously, is second, which surprises me, but there you go. Australia, then Indonesia, then Russia, then South Africa. In terms of exports, the real truth in terms of production of coal, we've got a lot, but the Chinese are digging up about 7 times as much coal as we dig up in total. They just use all of theirs. We export about 75%. to give you some idea of the scale of the Chinese production in coal and how insignificant we are. Now, not only are we leaders in coal, but we are leaders in uranium. And we use none of it and export all of it. And we have the largest reserve. Sorry, I'll just show you that full graph so you can see. Ladies and gentlemen, what are we thinking? We have more uranium than anyone by so far. It's ridiculous. And of course, you can't just use, some people are even exploring and working with thorium reactors, and wouldn't you know it? But we also have the largest reserve base of resources in thorium too. Not that we're using them, but at least 3 countries in the world are. So that's another exciting possibility. Look, we're just God's gift to, 4 billion years Australia's been sitting waiting with the most resources per capita of anything on the planet. This is our chance to show that even with this handicap, we too can destroy a grid and create expensive electricity. The other disadvantage we have is that we have, it's not a question of not having enough money, we have too much money. We've got so much money, we can afford to play experimental games with an electricity grid. And that's what we've done. This is a mass laboratory for grid management. Oh, sorry, that's Australia. It's the same thing. Our grid on the eastern seaboard there stretches all the way from Cairns down to Hobart. It's all connected to Port Lincoln, the whole lot. About more than 21 million people. It really is a phenomenal feat. And I'll go through and explain some of the logistics of grids and whatnot. But that vast distance is all synchronised on the same frequency. The power that flows there, 50 cycles a second, is not just 50 cycles a second everywhere, but it's in phase. It's the same 50 cycles a second. It really is a dance, a hum. And frankly, I'm amazed it works. Just phenomenal. You can flick a switch anywhere and it goes. And we don't think about it. Now, having connected all that up, for 40 years, Australia, from 1955 to about 1995, had falling electricity prices. We just got better and more efficient at it, and the prices kept coming down. Well, clearly that had to change. So then we, and compared to other places in the world, there's Australia in black, 4th from the cheap end of the spectrum. Compared to other countries for electricity prices, that was maybe 5 cents a kilowatt hour US in 1995. For those who are old enough to remember what that used to be. Now, I'm struggling to shift that one on. Have I pressed the wrong button or something? Good man. Now, excellent. Okay, and so what electricity mix were we using when electricity was cheap? Obviously, lots of free and cheap wind and solar, right? Because they're cheap, because everyone knows they're cheap. Well, let's have a look at what that grid was doing back then in 1995 or so, around here. This stuff is not wind, it's coal, and that's more coal, and that's gas. So that's all fossils, and then there's a bit of hydro and some, I think the hydro is this part actually, and the wind and solar is marked there in bright fluorescent green. Not exactly. Coal, gas, and there it is, the great moment in Australian grids when we started to bring in lots of intermittent, unreliable electricity. And you can see what happened to that great trend we had. 40 years of falling electricity, that's gone. Then we nationalised the grid. It's important to centralise a grid if you really want to wreck it. You can't leave it up to individual states. And then we got the carbon tax. That's a spike in price there, which was fixed briefly, sort of, but back to trend again with the current increase in the RET. Let's have a close look at the current mix of electricity. You can actually see what this shows is how little renewables we've added. It hasn't taken very many to really upset the balance. We've still got coal and gas there, and hydro in blue, and then we've got some. Wind is green, so there's wind, which started in about 2007. We've got wind power coming in. We've got solar marked in bright yellow. There's a spot somewhere. And rooftop solar is orange. That's starting to come in. That's becoming a very big player in terms of mucking up our grid, but it's actually not providing a lot of electricity. That funny combination. And there it is. Now we've achieved peak pricing. So congratulations to South Australia, beating the world in the competition to have the most expensive electricity. I thought we should look at what these failures down here are doing. Clearly they're getting it wrong. Maybe they've got too much wind and solar. So I looked them all up, and when I looked up Hungary, 4 nukes plus coal, oil and gas. Estonia, down the bottom there, mostly fossil fuels. Lithuania imports electricity, uses biogas a lot. There's no wind there. Poland is mostly coal. Slovenia is from nukes and hydro. France, of course, 70% nukes. Well, they've got... yes, pretty cheap electricity. So, ladies and gentlemen, in that bottom 10, there's none of them that are achieving anything in terms of renewable power or global climate change. So, moving on, the first step, if you want to destroy a grid, is to change the primary aim of the grid. Now, you may have thought that units like this were designed to provide electricity as cheaply as possible, reliably as possible all around Australia. But they have another purpose now. Instead of being an industrial electrical generation plant, they are now global climate controllers. You didn't know it, but that was making spring early, changing the spotted quoll, increasing floods and droughts at the same time. And yes, your lawn, probably causing cyclones that start with Y. There you go, floods. It's bad. So even if it does look beautiful, Rita sent me this shot in. Maybe it's just me. I think it looks great. Yes, same plant causing droughts as well as floods. It's very versatile. And instead, we decided to add better generators to our mix. We didn't need any new generators. We had enough, but we've added better ones to our mix, which are, of course, the solar and wind ones, because they have better beach weather. That's what we're aiming for here. Step 2, pick intermittent and unreliable ways to reduce CO2, because there's much better ways to reduce CO2 than using wind and solar, isn't there? I mean, if you really want to change the weather, you would use nukes, but I guess some people don't really care about CO2. The wind, of course, if we look closely at it, here's part of the problem. Look at this intermittency. This is 1 month, pick a month, any month. They virtually all look the same. We've got something like 5,000 megawatts of wind on the grid. Every 10 days or so, or randomly, it goes to almost nothing. That 5,000 megawatts will produce maybe 10, 50, 100 megawatts. It's virtually nothing, which means we can never count on wind to be there when we need it. It might be, and it might be running well, but no one knows. This is the problem. It doesn't matter if we made 50,000 wind turbines. We get a high cell over the side of Australia here. All of them are dead, all at once. It doesn't matter whether they're in southern Queensland and in South Australia. They all stop at once, which is what you saw in that last graph, which is done on a great site called Aneroid. If you want to look it up, you can see every month and you can check, and they're all similar. Now, with solar, rivers of cash. Solar's the big subsidy engine of renewables in Australia, much more so than wind. Even solar suffers from this. There's a cloud bank covering the east coast. And when that cloud bank went over, we lost 1,000 megawatts of electricity that day. How do grid managers manage these things when we've got so much electricity coming and going? Now, quick lesson on grid basics. You might hear we don't need base load anymore. You might hear that variability in demand is always up and down. But what you don't hear is that the lowest variability of any day of the year, 4 a.m. on Christmas Day, is about 16 or 17,000 megawatts. That's when everyone's asleep, nothing's happening, and everyone's on holiday. We still use 17,000 megawatts. That is base load, ladies and gentlemen. And the most efficient way to provide that is with giant turbines that spin at 3,000 cycles a second. So it's our summer load curve, and you can see solar helps a little bit with this peak up here. The winter curve, though, solar tends to eat into this curve. That's our breakfast time, and that's our dinner time. That's peak demand in Australia. And again, we still have this base load We use a lot of electricity even while we sleep. All those air conditioning units, all those fridges and freezers at Woolies and Coles. There's baseload, ladies and gentlemen. Now, the ABC can wish it away and tell us that it's not important, but we should be using our cheapest source of energy to generate this, and then we use more expensive stuff to deal with the peaks and gaps. That's how it used to work. We have a fragile system. You have no idea until you talk to an electrical engineer. It's amazing. This is the South Australian disaster where the interconnector shut down. The timing here is 2 seconds across this graph, from 15 seconds after 4:18 to 17. Everything was fine, everything was fine, everything was dead. Those guys in the control rooms, it happens so quickly. If we have a close look at that, they get down to measuring time in units like you would not believe, a 10,000th of a second. And they tell us that's when the grid fell over, at 4:18:15:84 p.m. So, yes, whew. Yeah, get with that one, Rolex, but you can't manage this on human scales. This is all pre-programmed. At that point, things had got so out of hand, the frequencies had fallen. South Australia was load shed. The entire state was cut off to save the rest of Australia from going down, because those kind of frequency falls tend to spread really fast through a network. So it was an automatic thing that kicked in to save the rest of the national grid from going black too. Frequency. This is hard. It fries most of our heads. Frequency. This is a 50 hertz signal. Yeah, I know, it's hard from that distance. It's a lot of ups and downs, 50 times a second. Why this matters is because electricity is AC. It's push-pull. It doesn't just flow the electrons down the line like water through a pipe. It goes back and forward 50 times a second. Now, if you get someone 50 times a second doing this and someone else next to them doing it out of timing, what happens? Well, it's just a disaster waiting. If we flow into another signal, and I feed in a signal at 50.4 hertz, so I've hooked up another coal generator, but I accidentally got the frequency wrong, we get this. We get interference patterns. Within a second and a half, you've gone to 0 volts. That's lumpy electricity. It's really not good for our gear. So electrical engineers get very upset, worried and anxious when the electricity gets outside of this band. Anything beyond 0.15 away from our 50 hertz, that's bad. And that's really important for people to understand, because it shows you how incredible it is that we manage our national grid with such tight requirements. And wind and solar don't help keep this stability, this frequency control. But the synchronous inertia, as it's called, or spinning reserve, frequency control ancillary service, that's a fancy way of saying we want to keep the frequency close to 50. And this thing is a giant coal-fired turbine. Inside there is a turbine spinning, thanks to coal and steam, at 3,000 revolutions per minute. It weighs around 600 tonnes. That's twice the size of a 767 spinning at 3,000 cycles per minute. That's inertia. You don't mess with that. This is why electricity was cheap. This kind of thing has efficiencies of scales like you wouldn't believe. And this is actually, though, ultra supercritical one. I don't think we've got one as advanced as China, but one day maybe we'll catch up. Yes, planes, that's right. Yes, like spinning. Think of the weight of a spinning plane at 3,000 cycles per second. That keeps the grid alive. Now, the frequency is connected to these turbines in a way that if you change the load, it actually pushes on the turbines to speed them or slow them. So the coal turbines are part of that network, and that is sort of a self-correcting system there. We never actually paid attention to frequency control when we just used mostly 2 sorts of coal. We didn't need to think about it. Now we do. So there's the base load again, just to remind you. This is what's called the duck curve, because it looks a bit like a duck. See the head up this end? The tail there. This is a graph of daily electricity, and as solar each year increased, it eats into the middle of the curve. So you may start hearing about the duck curve, because solar in the last few years has gone crazy in Australia. We've got something like a quarter of our houses have solar on the rooftops. Now, the problem with this, it looks great, free energy from the sun in the middle of the day when we sort of need it, but maybe not. The problem is your coal generators running at 3,000 cycles a second, you don't shut them down and start them up again for a few hours. You've still got to pay the capital costs, you've got to pay the staff and all of the other costs and the loans and the interest and all that goes on in that period. So you have to charge more for what you put out and the other times of the day. So it doesn't actually save money. By the time you've put in the free solar in the middle of the day, you're just paying more for the wings. We also end up paying more in price spikes for the ramp up here, which has got steeper as everything comes back online for our peak dinner time burst. And we could put in batteries, of course, and one of Tom Quirk calculated how much it would cost, and Paul Miskelly to convert South Australia to full batteries, and it was in the order of $60 to $90 billion for batteries to back up South Australia. And since the GDP of South Australia is about $97 billion, I don't think they'll be doing that anytime soon. The duck curve in South Australia has reached the halfway mark and they brag about it. But what that is really doing is destroying the economics of our cheapest providers. It's driving the cheapest ones out of the system. And we get that ramp up. All right, now, point 3, pick something that appears cheap. Here's a graph that's a killer. This is the trend line of countries and electricity costs. The more renewables they have, the more the electricity costs. Now, this is a bit unfair because it includes hydro as well and biogas. So take them out, and this is what wind and solar look like. There's a neat trend line there. So basically, the more wind and solar you have, we can calculate how many cents it's going to increase the price of a grid based on other nations around the world. If renewables was going to work anywhere, it'd be Flinders Island, which is diesel-based, not connected to the mainland of any way. It's run in the roaring 40s, lots of opportunity for wind and tidal. And the average now is 60%, they bragged, in 2018 for renewables. But they don't say when it becomes 100% that it will be cheaper. They promise that prices won't be going down even when it becomes 100% renewable. Where's that solar and wind rush coming? This is the Australian grid, $30 a megawatt hour. Sorry, that's hard to read. That's the cost for the last maybe 15 years. This is what's just happened in the last 18 months. So wholesale prices just took off. That is the spikes. This here was drought spikes. That was the carbon tax spike. This is this weird effect that's just happened. Again, you see mostly flat pricing, amazingly not going up. Wholesale electricity was the same for 15 years pretty much. Carbon tax was here. But boy, oh boy, this RET or something, we've hit a point where the system's falling apart. Prices. And I know I'm going to have to finish soon. Whoops. But it does fix something, and this is our GDP in manufacturing, and you can see we were rising and rising, but we've luckily stopped that now, and we don't have to worry about that anymore. The cost, it takes a lot of money, $3.7 billion 1 year federally, and $1.2 billion in subsidies in states. That's $5 billion a year to create a situation where our grid is really expensive. That was $600 a household. Did we have a plebiscite on that? Did we ask people, would you like to spend $600 to change the weather 100 years from now? Or maybe you'd like to keep it and fix your bathroom? And centralised control, we had separate state grids. They didn't really fall over, although they had problems, but they ran for 100 years. If you're going to put things under centralised control, you need to find the right person. This is Audrey Zibelman, activist Audrey. Malcolm Turnbull's brought her in from New York to run our electrical grid, and she said, I believe we're the last generation on Earth who can really do something about climate change, and she's in charge of our Australian Energy Market Organisation. So, technology has changed, she said, and resisting this change is a little like trying to resist the internet. They always tell us this change is happening to us, not that it is entirely artificially forced upon us by pure choice, not of the people, but of the politicians who made the rules. And there you have it, ladies and gentlemen. Which government spent $5 billion a year telling people they need to use the internet? Because it's a change that's coming. You know, just like that. All right. Now, I think I'm going to have to finish, aren't I? Because we need to... Otherwise, I can tell people the story of Tasmania, really. Okay. As quick as I can, Tassie has our Basslink interconnector. Not at the moment, it's not working. Back then it wasn't working either in 2016. This is just such a classic story. Centralised government. Tasmania built a gas power plant. It cost $230 million in 2009. Then they got more renewables and hydro. The carbon tax came in. This went out of business. By 2013, I think it was mothballed. By 2016, they decided to just shut it down. 3 months later, this is like rainfall and dam levels. So they had lots of water in their dams back in 2012. Then the carbon tax came in and they thought, we can make money. So they made money selling their water as electricity through the thing to Victorians, and they kept doing it even in El Nino years, which for those of us who are Australian know that means you don't get much water. So their dam levels fell, and these are their dam levels. And then, oops, they closed the plant about there, their last gas fossil plant, and then there the Basslink cable broke. So then they were islanded, as we call it in the electrical system, meaning they had no fossil fuel, no stable power. They had a 13% water or something they were projected left in their dams. They were really in trouble. They flew in squads of diesel to the Green State to keep it going. They didn't have a blackout. And sometime in that bottom around there, just before the water came back, in that, I think there's a star there, a big, that was the carbon tax. You can see what happened to their dam levels. This storm in Sydney, you remember that storm that came through in mid-2016? Well, that big storm was coming, and Tasmania, the guys at Hydro got excited. Wow, look, that water's coming. All that, you'd think, isn't that good? They got so excited that even though there were floods and flood warnings and incredible footage, they cloud seeded. That's right, ladies and gentlemen. It's the first example of cloud seeding to generate electricity in the world in the face of a storm coming. This is what centralised power gets you in electrical grids. Thank you, ladies and gentlemen.